mounds that we had, and we established correlations between those soils. And it's not very simple or very straightforward, part of the reason being, as I said before, regional developments are also modified by local developments. So you have to get a fix for every catchment that you're looking at, what the ages are of these mounds and occupations for any particular area, and then you work backwards and try to figure out why those correlations are not perfect and why the circumstances for one mound to be settled and another one is not, how those resolutions work out. On a regional basis, what we did back then is we looked at these soils and we tried to correlate them across the landscape. And we looked at the fact that across all sorts of landforms, there seemed to be an indication of wetting conditions sometime in the early Harappan period. So that, for example, wind, where it says aeolian activity, that means fewer winds. Fewer winds typically mean the end of a dry phase. Coastal changes, we started to find a little bit more moisture on the coast. Lake basins gave us indications that lake levels were rising. Fluvial sequences meant that the river channels were actually starting to fill up. And the soil chronology was very well expressed by the reddened horizons that you saw in the previous slide. So all in all, it gives us a pretty good indicator that this was not a local situation, it wasn't even a regional situation, it was probably an extra-regional situation because it cross-cut a number of landscapes and landforms from India into Pakistan and even into areas into Iran. So that was certainly a signal indicator that these things happen. Then Dr. Salangi made an excellent point. I didn't realize who was going to bring this up, but this kind of verifies it. There was a 4,200 BP drought event. Geologist Michael Staubwasser from Germany identified this incredible change in oxygen isotope and other isotope ratios that shows an incredible drop in an incredible drying and transformative phases at the end of the urban Harappan phase. So those kinds of indicators give us an indication that not only are we looking at small-scale events, but they're very, very extensive, and they're coming at you from a variety of different records. We worked with a climatologist, the late Reed Bryson, and he gave us some additional information on the movements of the circulation systems in the monsoon. The monsoon is really the trade wind area. I don't want to get into all the climatology here, but it basically represents the coalition of the northeast and the southeast trade winds. So the trade winds themselves are a measure of how impactful the monsoon will be. And what we did is we combined that information with discharge stream information on a variety of stations along the Indus, and we put together a model that essentially said that there was a major change in discharge over the course of the Harappan period. You could see that huge spike in the discharge of the Indus during the Harappan period, again signaling moisture environments at the beginning and progressively drying trends. In addition to that, we saw some other information. We found out, as many of you had commented, that there were rains here in the winter. Well, in the winters during the past 5,000 years, the rain was actually very significant. It wasn't monsoon-like, but it certainly affected the seasons, and it's clearly, if you're looking at it in cultural attempts, it could have affected crop activity. It could have changed irrigation systems. It could have done all these things. This is just one particular model that shows that it changed significantly. Rainfall seasonality patterns overturned. Monsoon contribution decreased over the course of time, ultimately disrupting climate equilibrium, and the soil dates confirmed and corroborated some of these trends. Now, there was an article that came out 3 years ago in the Proceeding of the Natural Academy of Sciences that actually used a simulation model and came up with very similar data, except that in terms of settlement information, it did not take into account that Harappan adaptive strategies didn't all of a sudden change when the climate changed, because there's normally a time lag, and there's an adaptive strategy that's associated with that. So this becomes one of the real interesting problems that's archaeological and anthropological in nature when you're using these types of simulations as baselines for introducing environmental change. There's no cause and effect directly necessarily, but it's giving you a trend and something to explore. So you would use interdisciplinary research, doing some faunal analysis, doing some paleoethnobotany and pollen analysis to see how these things work. The soils, as I said before, we've identified the soils, and if you look at that simulation model, there is no change. Soils are stable. So that is a very confirmatory field indication that we had periods of very rapid successive soils occurring in the early Harappan, which means that these two models coincide. And finally, there is the turbidite information off the Makran coast, which is very important if you're starting to look at the sites in the lower Indus that are showing you major fluctuations towards the end of the Harappan period, and a drying phase that is pretty much irrefutable. Now, one of the other things, and I'm not going to go into this in any great detail, is looking at the C3 and C4 climate information. The C3 and C4 is a stable isotope carbon information that gives you an indication as to whether or not your environment is semi-arid or arid. And so we took some of that information from the natural layers and some from the cultural layers. And it's not entirely straightforward, because some of these plants are selected for use in the cultural deposits. For example, if you're seeing an extensive C3 component, it may mean that people are responding to environmental stress. So it could be an artificial indicator that it's not really the environment, it's that people are running to get that information because the environment has changed. So these are, again, the types of interpretations that we have to use as a baseline and introduce the cultural filter to actually gain a true interdisciplinary perspective on all of this. So, provisional hypotheses that we've generated. First, Harappan landscape histories have to be reconstructed through probing of the sealed mound surfaces, submound surfaces. The drainage basin is the baseline for linking flood activity, landscape, and mound histories on a regional basis with some modifications. These histories can be fed into regional climatic models that point to changing circulation prior to and following the 4.2 KYA event. Higher discharge and shifting rainfall seasonality seem to disrupt land use somewhat and subsistence attendant to the Harappan demise. We don't know all the details of it, but it's certainly pointing in that direction. As I said, there could be a lag effect. And stable isotope studies refine our understanding of natural and cultural environments of the pivotal middle to late Holocene. So, using that information, we try to project some of it into the Mohenjo-Daro study, which we just started looking at literally days ago. Again, the critical element of the drainage basin. Look at the lower part. That is where all the deposition goes on. That is where all those Oxbows that Professor Salangi showed, that's where it all happens. This is in the areas of like Chano Daro and places like that, where you're going to see a tremendous amount of stream activity that can actually overhaul sites, so that you may have no sites preserved on the surface, but plenty of them in the subsurface. These things are all very delicate subjects. So the strategies that we need to look at is the river and the city. In some cases, I would assume that Mohenjo-Daro, having been built, is such a huge obstacle to some flood patterns that when it's not getting buried, it's moving the river around. It is in the way. It's a nuisance for the river. So you can look at these situations, and the important thing is to track the drainage lines, which is one of the things we want to do with this project. Site formation process is obviously very critical, as Dr. Salangi indicated. The encountering of all these pieces of cultural information are very, very critical in terms of trying to put this thing together. Getting paleo-environmental data is very, very important, obviously. And recalibrating the climatic signals in conjunction with all this other information is going to be very important as well. Now, if you look at the model of where the Indus is right now, and that purple line is the line of the river. Yesterday we were coming up here, and Michael said, you know, I was at this place called Amri a while ago, and we looked for it, and the villagers told us it was gone, and look where it is. Right by the Indus. It's gone. These are some of the ancient reconstructed lines of the ancient Indus. They were looked at in terms of some very general guidelines and some primary major channel scars that were tracked. This is based on some of the work that Lou Flam did. And you can see that there are so many little drainage lines coming in the lower Indus that it's becoming pretty messy. So let's take a look at a time delay model of what's happened to the Indus over the past 30 years. That's the present channel. Pay attention to the area in the red boxes. Year by year, this is what's going on. Lots of changes. Until 2016. And then comparing all of that, we look at two very major shifts in the primary course of the river. And this has occurred in 30 years. Now, there's obviously been some human interference in all of this, but nevertheless, these are changes in the primary stem of the river. So these are all the sorts of things that we have to take into account. We had talked about Oxbows. This is an Aster digital elevation model of those Oxbows. We point out what they are, take a look at them, and those are some of the major channel scars that we've identified. What's interesting in that is anybody who studies basic geomorphology looks at how oxbows form. And what you're seeing is you're seeing a migrating river, much like the ones I showed you and Dr. Salangi showed you as well. And they go from A to B, where eventually that neck of the oxbow is cut. And what ends up happening is that oxbow becomes a swamp. That swamp becomes a swamp and a meander scar. What's important about that is that these are areas in which flora, fauna, and people concentrate. They utilize these resources. That's A. The second thing that's important is those deposits are always datable. So if you run a transect across those oxbows that we defined, we can probably put together a reliable stratigraphy on when that oxbow formed, what the history of the landscape was, why people moved from one location to another, why other locations were swept away in the creation of these oxbows, and on and on and on. So there are very, very favorable areas of research when you're doing this kind of work, and hopefully we'll be able to do them. This, again, is the drilling machine that was used in the 1980s. These are the drilling machines that we use in North America. They're a little smaller, just as powerful. Whether or not they can penetrate through mud brick, I don't know. I suspect that if we fit it with a proper bit, we might be able to do it. And this is what you do with it. Dr. Salangi showed you wonderful cores, and our objective at this first stage of the project is to simply date these things. So you just date the deposits that are most organic. You looked at the intervening deposits, and you can get all kinds of information. You can find a soil in there, which means you had a stable landscape at a certain point in time. And you can also calibrate the rate of flooding, which tells you how the landscape changed and how the environment's changed in response to all these external controls. When you put these cores together, and Dr. Salangi started to do it, you see patterns repeating across space. They will show you, in many cases, where a stable soil is. Over here, this is an example from northeastern United States. You see all those dates and those yellow soils. That indicates that there was a stable surface there over a certain period of time, not actually that far distant from Harappa in terms of the chronology, but these were stable surfaces that supported sites, and not mysteriously, a lot of archaeological sites occur there. This is Michael's map, the one that you're seeing that he showed before. We're looking at the new site and the old site, and this is the array of cores that we had before. And then this, a model of the subsurface, of the surface, and taking a look at this, you can see that we stick these cores in, and we just use very briefly a series of some of these cores that my assistant put together, and you can see how the density changes in various portions of the site to the degree that this can be modeled in 3 dimensions. And all this, you see the clustering of the yellow, the sands in particular areas. Now we have 70 more points that we can plug into this model and recalibrate it. And so our objectives for the dry coring program is, first of all, the sedimentology, to look at stream dynamics in a very general way. Dr. Salangi has gone a long way to doing that. Dating of organics, as I said before, in the Oxbows and in areas that are very, very heavy clayed. You saw some of his profiles that showed you very deep accumulations of clays that are all datable. Whether there are questions about how accurate those dates are, but we can talk about that at a later time. They certainly give you a general idea of how old those meanders are. And then site formation histories. When you look at the areas outside the perimeter, what kind of information are you getting? Are you getting expected habitation areas? Do you have clustering of certain artifact sets? Have they mobilized extensively? Have they been dragged by the river all over the joint? All these things are very possible. And finally, the Oxbow studies themselves for getting the information on the ancient landscape. And finally, because this is near the coast, and you're starting to get the effects of sea level history, and an aspect that I did not mention extensively, which is tectonics, which has a lot to do with what's going on over here. So if we want to conclude final statements, you need to refine drainage basin histories as much as possible. That's the main thing you have to do at any site you're going to work on, as far as I could see. Incorporate independent climate signals to refine fluvial systems models. Improve site prospection techniques, especially for the lower valley, and address site formation issues at Harappa, Mohenjo-Daro, and the secondary sites so that we can get a perspective on all of this. Thank you very much.
So what a wonderful session we had. My hats off to Department of Culture and Antiquities for organizing such a nice and informative sessions. And all these sessions are gelling together very nicely, and that's what I appreciate. Like 3 speakers we had in this session, they gel together so well. One is supporting the other one, so it's a delightful experience for me. Of course, these subjects are very close to my heart. So thank you very much, all the 3 speakers we had, for a wonderful job you have done. And the job of summing up is also with me, so you have to bear with me for a few minutes. Starting from Professor Jensen's paper, who gave an overall view of Mohenjo-Daro with the help of very old photographs from 1920s and up to now. Then aerial photographs of Mohenjo-Daro. Well, the aerial photographs of 1920s, which we hardly find nowadays. He discussed the earliest articles about Mohenjo-daro, and then the most heated debate, one can say, is about the stupa, whether it is stupa or not. So it is a lot of work for us. So he has given us a lot of work to think and work on, and let us see what it comes up and how we are going to solve this mystery about the Great Bath and the stupa, which is, according to him, is not stupa. And then he pointed out the debate about how the architecture can let us date the site. This is another thing. Well, of course, architects understand that better, but I do agree with that, that we can do dating through many different aspects, and of course, architecture is one of those aspects. Then the outlet of Great Bath, which according to him was also misjudged. So this is another thing to think about. And why old and new is important. This is what actually was the gist of his talk, and about unpublished plans of Wheeler, which we never saw before, were discussed, and then different technology of wells start in different stratas, that how it is depicting different dates. Then the drains of the houses, how these drains were formed, and the wells of highest quality and highest number of wells at Mohenjo-daro. Then he showed about his inventory of objects comprised of 38,000 of objects, which is another thing to think about and study through. Then the photographs of the conservation work. Yes, this is very important, which I would like everybody to consider, that how the conservation started, to study the drawbacks, the good and the bad points of the conservation steps which were taken from the very beginning, and how it has helped to deteriorate the site, not in fact to improve the site. So that is another thing he discussed. And then the capacity building. Yeah, he's very right. We train people and then we are not able to retain them with us. So that's another point to think about, that how to retain these people. Then the oldest maps, um, how to actually, in my opinion, okay, I don't want to give my opinion here, but just to discuss that, but I think we need a documentation center where all this material is lying, and anybody who wants to do research, they can just go and have access to that. Then Professor Jensen discussed the diggings by George Dales and Mark Kinnear, and about the hypothetical reconstruction of all those structures which I just spoke to you about. And then the drillings done by Professor Jensen, of course, that will be very helpful to study in with the drillings of the present day. Then another thing he discussed was the Sindh data bank, which he has compiled, and we must have an access to that also. So how would these controversies will be clear? This is one of my question, and we need more studies from old records to present scientific studies. So two objectives have come out of his talk, which I think that we need to work on. The next talk was for Professor Salangi. He spoke about the core drilling work carried out by him, and then, like he said, that the final reports has yet to come up. So, what were the objectives of those core drills, which he discussed? And then, of course, first was to see the extent of the city, and then the study of the sedimentological, natural layer, and organic layers. And then he discussed through the satellite images, core samples. Of course, core sampling was quite challenging. I was in touch with them during this process, and the water level was one of the major issue or a challenge which they faced during the core drilling, and which Dr. Sulangi discussed. And I was quite happy with the triple tube core barrels which they have used. I think that that was the most safest way to get those drills done. Then he discussed about different cores and the samples and the locations which he had for the core drilling, its storage, and the studies of half of the core which has been studied, and half of it is there for us. So that is more than welcoming that we can all try to study those cores which are there. That would be, of course, very interesting from the archaeological point of view. What he has done is through the geologist's point of view. And organization of data, which is one of the major parts of core drilling. So they have done it very well, and I'm quite happy with that. Coming to Professor Joseph's talk, who spoke about geoarchaeology of Indus Valley and river mobilization, this was one of the most fascinating talk I've heard today. Uh, I don't want to say that others were not interesting, but this was really, really interesting and very well put up. And the 3D animations, which is one of my favorite thing, was very, very nice. So he discussed the river system of Indus starting from the Harappan side and their fluvial system, settlement geography, and how the sites end up and why they are there. First, why they are there and how they end up. So this is all can be reconstructed through the studies which he has done, and how river system works, which is one of the major thing about Indus Valley sites. So I think it is very, very important to study this way all other sites and